Hey folks, today's topic is quadratic functions. So some of this will feel a little bit repetitive, especially at the beginning when I have to explain again quadratics. But you'll get some new stuff when we look at converting between the different forms of our quadratics. So first of all, quadratic has when we graph it, it has a specific name. Hopefully you remember what that's called. So a line is when you just have a function, or you have a function that only has x in it. And when we get x squared as the highest power, we get this shape, and it's called a parabola. Now we're going to talk about what kind of parabola. This is what we would call a concave up parabola. You know, if it was reflected, it would be called a concave down parabola. We don't have convex parabolas. We only call them concave up or concave down. So on the back of today's notes, I'm going to talk about the shape. That's what I mean by the shape of that parabola, concave up or concave down. And you must write the word parabola too, because we want to make sure that we're identifying the type of graph that we have. We also have this important point here. You might remember this from your Algebra 2 days. This was called a vertex. And the coordinates of the vertex are designated H and K. And then there's one other characteristic that I want to talk about. It's this line here. If you look on either side of that line, what do we call that when a graph reflects or looks the same from left to right? We call that symmetry. So this is what we call the axis of symmetry. And the axis of symmetry is an equation. So this is a vertical line, and all vertical lines have the equation x equals, and it's x equals h, which makes sense because that axis of symmetry goes right through the vertex. So the x value of the vertex should be the same as the x value used for the equation of the axis of symmetry. A couple of tricks along the way. We'll talk more about that when we get to the back and do some examples. I want to quickly run through reviewing this format. Remember this, you might remember this from I hope you remember this from our transformation of function notes in the last unit. So let's start off with H and K. H and K are what we call shifts. The H is next to X, so it moves in the X direction, but it does the opposite of what it says. This is not next to X, so it does the Y direction, and it does the same as what you would, whatever that number is. We also have this value out front. The coefficient will tell us two things. It will tell us whether or not our graph is a stretch, a shrink, or a neither. And that's determined by the size of the absolute value of this number. So I don't care if this number is positive or negative. We're going to have a stretch if the absolute value of that number is bigger than 1. You're going to have a shrink if that absolute value is less than 1. And it's going to be neither if that absolute value equals 1. And then last but not least, we have whether that value out front also determines whether or not our function is going to be a reflection. So this also determines if we have a reflection. It's a reflection, yes, if a is less than 0. In other words, if a is negative. And it's a reflection, no, if a is greater than 0, or in other words, if that value out front is positive. So when we have a reflect yes, that means that our graph looks like, reflect yes would be a concave down. Now I usually just use CCD, concave down parabola, and then no would be a concave up parabola. So we have this form called vertex form. Why do you think we call it vertex form? Because the H and the K make up the vertex. Pretty straightforward there. Then we also have this form called standard form. Standard form is not as helpful. It does give us a couple of things. First of all, this value out front still determines stretch, shrink, or neither, and then reflections. This value at the end, the constant, turns out to be the same as the y-intercept. Remember, all y-intercepts have an x value of 0. And then to find the AOS, to find the axis of symmetry, we have a little equation, AOS, x equals negative b over 2a. Now you might remember that from the quadratic formula. It's the first little part of the quadratic formula. It finds the equation for the middle of that parabola. So our goal today is to be able to take a function, convert it from standard form into vertex form, and then use that vertex form to identify the shape, the location of the vertex, and the equation for the axis of symmetry. Before we can do that, though, we have to review something called completing the square. So I'm going to teach this kind of going forward, reviewing some stuff that you already remember, and then we're going to use that review to help us figure out this completing the square algebraic move. So if I take x plus 5 squared, don't be that kid that says that it's x squared plus 25. It's not true. Put a number in there and see if it works out. It won't work out. X plus 5 squared means x plus 5 times x plus 5. Now I would start to distribute. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Now I can combine some like terms, x squared plus 10x plus 25. Now what you want to be able to do is you want to be able to look at this and go right to this without doing this work. So this is what Miss Musio calls a special double. This is one of our algebraic tricks that if you learn it, it saves you a ton of time. So see if you can come up with a pattern. How could we have known that we would get this trinomial from this binomial squared? See if you can see a pattern. Now let's test your theory with x plus 3 quantities squared. Well, if you distributed this, you'd get x times x would make x squared. Then you would get 3x, and then you'd get another 3x, which would end up being 6x, and then you would get 3 times 3, which would be 9. So there's this sort of shortcut here that we could take this number and multiply it by 2, and take this number and square it, and we'd get that value at the end. So let's have you try one more. X subtract 7 squared equals. Give you about 10 seconds. You should be able to figure that out pretty quickly. You should get x squared, subtract 14x plus 49. All right, so now we've got this idea of how to build this way. And like I always say, mathematics, it should be able to be done in both directions. So if you can go this way, we should be able to start with this and work our way backwards. So let's say we had x squared plus 20x plus 100. This should be x and then something and then squared. What should be that something that we would put here? Well, I've got to find something that multiplies by 2 to give me 20 and multiplies or squares to end up being 100. And find out that pretty quickly. It's the number 10. Let's try another one, see if I can stump you here. X squared subtract 30x plus 225. We want to repackage this thing as a binomial getting squared. So I've got to think of something that when I multiply by 2, I get this. When I square it, I get this. And hopefully you already figured out. Should be subtract 15. Okay, so now I'm going to take away, I'm going to give you even less information, but we're going to use that little bit of information is all we need to be able to answer the question. So I'm talking about x squared plus 16x plus blank. And what we want to do is we want to take this and repackage this as x with a squared. Okay, so see if you can figure out what number would have to go on the end here, and then what number would have to go in the parentheses. So I'm giving you, all you really need to know is this number right here to be able to figure out the other two. Well, hopefully you figured out this one first, because it's usually easier to find this. Because what should we do with this number? What's the relationship between what we call the b term and what ends up being in our binomial? Well, it should be half. So I'm always going to take this thing and I'm going to divide it by 2. 16 divided by 2 is positive 8. Then I just think of this as seeing that squared there. That reminds me what to put it back up here as, and that's 8 squared, which is 64. Let's try another one. X squared subtract 22x plus blank. And I want you to repackage it as something with an x squared. All right, let's see how you did. So I want to cut this thing in half and then square it. Trying to find a good color here. Yeah, I guess, purple's too dark. What about a nice blue? Cut it in half. Negative 22 cut in half is negative 11. Then I need to square it. Negative 11 squared is still positive, right? A negative times a negative is a positive, and it ends up being 121. So this is what we call completing the square. This move right here, maybe I could put a little block around this. This is what's called completing the square. So it takes something that's in this expanded, what we call standard form, and turns it into this stuff that's going to look like vertex form in a minute. So let's flip over. So I want to take this and repackage it in its parentheses form. Now I can't do that until I complete the square. And I can't complete the square as long as this 4 is in the way. If you remember here, we had a blank at the end of this. So what I'm going to do is I'm going to move this 4 out of the way, and I'm going to create a blank in its place. So this is going to look like x squared plus 6x plus blank. Now I can't just ignore the 4. So I can't just get rid of it. So I still have to count it. And I also have to undo what I created here. I mean, if I add, let's say the number is going to be 11. If I put 11 in here, I'm not going to, 11 plus 4 is not the same as the original equation. So I need to undo what I did there. So whatever I'm going to put here, I'm going to put there to cancel it out. Now I'm going to repackage this so that these actually doesn't look like they cancel out, but they would mathematically or algebraically. Okay, now I'm going to repackage. Remember, these 3 things are going to come together to make something squared, and then these are going to make something on the end here. So how did we figure out this number? We took this, cut it in half. So 6 cut in half is 3. 3 squared ends up being 9. Now whatever's in this blank is in this blank. But I don't want to mess this up. I like this in its new format because that's what vertex form looks like. Vertex forms looks like something inside of a squared with something added on the end. So I'm going to leave this in its format, and these 2 things are going to come together. 4 take away 9 ends up being minus 5 to make the rest of my equation. So now I have an equation in vertex form. F of x equals the quantity of x plus 3 squared subtract 5. Is this a concave up or concave down parabola? Well, what's the value out front? Positive. So this is a concave up parabola. Notice I wrote parabola. You don't have to write concave up if you don't want to. You can just write CCU, but you must write out parabola. My vertex, remember our vertex were H and K. These shifts help us figure out our vertex. So this is going to be a shift of negative 3 and minus 5. Opposite x, same as y. And then my axis of symmetry is always x equals whatever the x coordinate is of your vertex. So that would be x equals, my x coordinate is negative 3. There you go. All right, let's try another one. Actually, no. Pause. You try this next one. You should be able to do the next one now. All right, let's see how you did. I'm going to first, I call this blank it up. Plus blank, plus 41. Subtract blank. I need to undo the blanks. Now I'm going to start to repackage. This is going to be x squared. Take this, divide it by 2. That's negative 7. Negative 7 squared ends up being 49. Whatever goes in this blank has to go in this blank to undo it. Don't forget, these two come together to make our constant at the end. So 41 take away 49 ends up being negative 8. So now I can take this whole thing and rewrite it as my vertex form equation. Vertex form is so much nicer because we can figure out all this information based on just the equation. So the shape is going to be a concave up again. The vertex is going to be at 7, negative 8. And the AOS is going to be x equals 7. All right, so now we get to something a little bit different. And if you remember when you were factoring, go back to your factoring days in Algebra 1, and we factored with a coefficient of 1 was a lot easier than when we tried to factor with a coefficient that wasn't 1. And this is the same sort of scenario. So you have to take care of this first. You have to get this out of the way first. In other words, you cannot complete the square if, let me try to circle it and draw a little note. You cannot complete the square unless this is 1. This must be 1. If that's anything other than a 1, this trick of cutting in half and squaring doesn't work. It's not equal. It's not algebraically sound anymore. So let's try this again. So what are we going to do with it? Well, get it out of the way. What I can do is I can then, if I don't want this to be a negative 4, what would I have to do to make this worth 1? I can't subtract 4 or add 4 because it would either, if I include the x squared, it would cancel it out altogether. Or if I just added 4, these are unlike terms. So what I'm going to do is I'm going to divide out. I'm going to divide it out, and I'm still going to do all of the blanking that we did here, all the blanket ups. So I'm going to take out a negative 4. Okay, what's that leave behind? A positive x squared. Now look, you took out a negative 4 out of negative 32. So that's going to leave behind positive 8. And then this is where we're going to put that blank. We don't know what it is, but it is going to get included by this negative 4. Now we push the negative 50 out of the way. And then we need to undo this blank. So this is worth negative 4 blanks. To undo that would be positive 4 blank. Now, if you notice up here, it was always minus, and it was minus again. That's because, well, this was plus, right? And you look down here and you say, well, this is still plus. The problem is this negative 4 needs to get distributed to whatever number we put in here. This number needs to be positive because we're squaring. So I guarantee it's going to be a positive. But because it's getting multiplied by this negative number, we need to undo this negative 4 times the blank with a positive 4 times the blank. All right, so now we can start the next level, negative 4, parentheses squared, with my x again. So now we can do exactly what we did before. I'm going to take this, divide it by 2, so that would be plus 4. I'm going to then square the 4. That's going to make that a 16. Since we put a 16 here, we're going to put a 16 here, and then minus 50 plus, what's that going to be, 40, 64. Minus 50 plus 64 is going to be plus 14. So now I have an equation that's in vertex form. My shape, my coefficient this time is negative, so my shape is going to be concave down this time. It's a concave down parabola. The vertex is negative 4, 14. And the axis of symmetry is x equals negative 4. All right, I'm going to encourage you to pause here, see if you can do the next one all on your own. All right, let's see how you did. Cannot complete the square if your coefficient is anything other than a 1 in front of the x squared. So I'm going to factor that out first. So that's 5 times the quantity x squared. I took out a 5, so that's still negative, but it's now a 6. And then I don't know what's in this spot. I moved the 49 out of the way, and now I need to undo. This is a positive 5 blank, so it's going to become a minus 5 blank. Complete the square. 5x, I don't know what it is yet, and a squared. So I always know the next step's going to look something like this. And then now we can actually try to figure this thing out. So negative 6 cut in half is negative 3. Negative 3 squared is 9. Goes in the first blank, goes in the second blank. These two come together. So this would be 49 take away 45, which 49 take away 45 should be 4, shouldn't it? 49 minus 5 times 9. Yeah, it should be 4. Huh. Plus 4. So then my function becomes, what color was I, purple? F of x equals 5 times the quantity, x subtract 3 squared plus 4. My shape, my a value is positive, so it's going to point upward. This is a concave up parabola. My vertex is at 3, 4, and my AOS is x equals 3. Okay, so completing the square is the move that we use to convert quadratic functions from standard form into vertex form, because vertex form is much easier to talk about some of the characteristics of that parabola.